Hello, I'm Stuart Large, Product Line Director and Business Development at Fotech Solutions. I'd like to talk to you about the integration of two technologies, distributed acoustic sensing, which is a form of fibre optic technology, with UAVs, unmanned aerial vehicles. And this is for the purposes of protecting pipelines with a rapid response to a threat. Fotech was established in 2008 to develop the distributed acoustic sensing technology, and this is in use today, protecting thousands of kilometres of pipelines, perimeters, borders, and it's even been used down oil wells, gas wells, and now we're seeing it emerging in smart cities and in transportation. So our company combines talent from across the globe. We operate in numerous countries, and we consider ourselves as operating at the leading edge of industrial photonics, and we have a depth in technology expertise and software. We've been in the news recently as we were acquired by BP LaunchPad at the end of 2019. This is a very exciting step for Fotech, as it's bringing tremendous resources to the company, allowing us to accelerate investment in development of our technology and to expand our team. The idea of DAS is to protect pipelines, and this particular example was really showing this in practice. This example is in South America. There's a pipeline running through rainforest. It was very early in the deployment. We were actually doing the site acceptance test when we recognized some vibrations occurring near the pipeline. When we pointed this out to the client, at first they were a little suspicious because they thought this was such a remote area. They didn't really believe there could be people in this location. But we were insistent, we were confident that this had to be man-made activity by its nature, and therefore a security team was dispatched to the site. And to everyone's surprise, when they reached there, they did indeed find this team of men who were mining geologists. They were drilling holes in the ground very close to the pipeline with the intention of detonating explosives as part of their seismic survey. Now you kind of wonder how on earth this could happen. Had they actually detonated those explosives, then they would have blown up the pipeline and quite possibly injured themselves, or worse. But what happened was they were relying on GPS for their positioning, and because of the tree canopy, the GPS wasn't functioning properly, and just by chance they had ended up very close to the pipeline. Now, as you can appreciate, time was of the essence. We got there in time with the security team and were able to stop those activities. Had it taken longer, then the worst could have happened. Now actually, the response to most of the threats that DAS is able to detect needs to be rapid. That could be detecting hot tapping, so thieves trying to drill into the pipeline. It can be damage by excavation. It could be detection of a leak, so you want to be able to respond quickly and turn off the flow of the pipeline. In the case of hot tapping, we've seen clients who are really suffering because they may fortuitously discover that the criminals are attempting to tap their pipeline, but when they disturb them, if they're too far on in the process, they actually can just run away and leave a leaking pipeline. So a kind of botched attempt. And this is really expensive. In one case we're aware of, it cost a few tens of millions of euros to clean up the spillage after those criminals had gone away. So we really want to get to site before this develops into the worst case. So what is distributed acoustic sensing? Well, it's a fibre optic sensing technology. We use a standard fibre optic cable as brings broadband to your home or business. And we use a laser to send pulses of light down the fibre. If there are disturbances in the ground around that fibre caused by footsteps on the ground, digging activities, the movement of vehicles, or even fluid escaping from a leaking pipeline, these disturbances will affect the light that is transmitted and reflected in the fibre. And this is what we're interested in. We're looking at the changes in the characteristics that are caused by acoustic energy impacting the fibre. Now, a system could monitor up to 50 kilometres of fibre in one direction, and we might have two channels, so we can monitor in two directions. We can connect multiple systems, as shown here in the picture, end to end along the pipeline, so that we can actually cover hundreds of kilometres of pipeline. And we can network our systems together in order to have one system that works all together through one common user interface. Now, key to all of this is the reliable, dependable alarm system. Now, each of the DAS interrogators distributed along the length of the pipeline will be reporting events that are detected. These events are recognised by particular software algorithms that recognise the unique signatures of the activities, because of course walking sounds different to digging, which sounds different to a vehicle moving about. So these events are reported to an alarm server, and here they are accumulated over a number of events or over a period of time to decide at what point a certain level of alarm needs to be raised, starting with a green, going to amber, and going on to red. And at each level a different response will be required, and the alarm may be communicated to different groups of people. Now ultimately, once we reach that red level of alarm, where we're seriously concerned about a threat to the pipeline or believe there may be a problem, it's time to respond. So what we believe to be one of the most effective forms of response now is with a UAV, Unmanned Aerial Vehicle, or known to many people as a drone. Now there are many different types of UAV on the market, and we'll come to that in just a moment. But a UAV can provide many benefits. A significantly faster response time, because of course the UAV can fly straight along the pipeline or in a single straight direction from where it launches to where the threat is. Whereas people of course have to make their way by roads and perhaps navigate quite a convoluted way to get to the site. And then there's no risk to the lives of the security team. By the nature of the type of people that are trying to steal oil from a pipeline, they're obviously not particularly pleasant people, and in some cases they are armed. And it has been known on numerous occasions for security teams to be put at risk by armaments. The UAV also provides an opportunity to assess a threat before human responders actually arrive, perhaps to make an arrest. So we're able to see how many people are present, and if they are armed, and perhaps to decide what might be the safest way to approach them. It also provides a deterrent. Once the criminals realise that they've been discovered, they are unlikely to continue their activities. So hopefully you can get the UAV to the site before they have done damage to your pipeline. And they know that once they've been spotted, and they can be alerted by a speaker system or bright LED lights shone upon them, and then they give up what they're doing because they know they won't be able to get away with any product. The UAV can acquire evidence that could be used in court for prosecution, and it also provides the ability to follow intruders after their discovery, particularly where perhaps thermal cameras are carried by the UAV. So in deciding on the right type of UAV for a particular project, there's a number of different specifications to think about. Vertical takeoff and landing. Of course, this means that you can house the UAV in a fairly small pad, perhaps inside a box with a lid that can automatically open to let the UAV fly out, and it can then fly, and then once it reaches location it will have the ability to hover. That's the benefit of this helicopter design, whereas a fixed wing design may have to fly in a circle, and that in turn could mean it loses sight or isn't able to get the right vantage point to look at the criminals on the ground. Of course, the choice of power plant and fuel is important. This affects the safety and the range, and of course the reliability and level of maintenance required for the UAV. Then we get to endurance, so how many hours it can spend in the air and what range it will have. Speed, which affects the response time and the range it can cover. And then of course the data link. This applies not just to navigating the UAV, but also the ability to send its data, the video or the thermal camera feed, back to the place where it's going to be viewed. And then we really want to have autopilot. You can't expect to have a pilot in control of this UAV the whole time, and not of it to be most efficient. It needs to be able to fly on a path to the coordinates given to it by the DAS system, and reach the location. We'd be looking really for the pilot to provide air traffic control with information about the flight of the UAV, and then to take over in the very unlikely event of some kind of failure. Then also you need to think about payload. We want this UAV to carry a decent quality of camera, thermal imaging, and perhaps other things required for the deterrence, such as the speaker system or the lighting. As we mentioned already, we want it to be able to hover when it reaches the location. So integrating these technologies together is the key. The distributed acoustic sensing technology recognizes the threat on the pipeline and then communicates that to the flight management system of the UAV, so that the UAV can fly automatically to the coordinates that are provided and respond in the quickest possible time. So let's look at a couple of examples of how this might be deployed. This is a case where distributed acoustic sensing has recognized hot tapping in India, detected 26 hot tap attempts in just 6 months, so a high level of activity here. Now, you don't really want to be sending out personnel every single time to inspect each threat, when in actual fact it's cheaper and faster to fly your UAV to the site. Now, we need to consider the response time that's going to be necessary, and response time is determined by the depth of burial of a pipeline, the soil conditions, which affects the speed at which a hole might be dug, and the method that might be used for digging. So depending upon where the location is, you take a view on whether machinery could be brought to location to dig more quickly, or whether it's going to have to be dug by hand. And that's really what determines how quickly you're going to need to be able to respond so as to deter the criminals from going any further, and you want them to stop before they dig the hole deep enough to reach the pipeline. So this, of course, is the response time required of the UAV. So that means that we need to raise an alarm using the DAS system, and then we need to launch a drone, and then we need to fly it at the highest possible speed to reach the site. So that, and we may also have to consider what is the ultimate range of the UAV. So let's consider a worked example here. So consider a case where a pipeline is buried 2 meters deep in the soil. Perhaps that soil's got some clay content, and we realise it's going to have to be dug by hand with a spade or an axe. So in this case, we can estimate it will take maybe around 45 minutes to dig down to the pipeline, and that sets our response time. So the DAS system should be able to recognise the digging, elevate it to a red level alarm, and communicate that to the flight management system of the UAV, and then the UAV will be launched, and all that should be done within about 5 minutes. Now once the UAV is in the air, this particular model we're looking at can fly at 90 kilometres an hour, and therefore it can cover 60 kilometres in 40 minutes of flying. So that means the UAV can be no more than 60 kilometres away from the point at which the digging is occurring, and therefore we could have no more than 120 kilometres of spacing between multiple UAVs. And if we reduce this to say 100 kilometres, that gives us a safety factor, because we do need to think about a case where we might have to fly against the wind, and therefore, although our airspeed might be 90 kilometres an hour, our speed over ground would be a bit less than that. So another threat to pipelines is just from accidental damage. This can be caused by digging, perhaps for another reason, such as laying a cable, trenching activities, or to lay another pipeline. And it turns out that between 1994 and 2013, around 12.5% of pipeline damage was caused by excavation. This is actually something that's very easy for DAS to detect. It's a big signal, and in this particular case, Fotech actually identified 2 locations on a pipeline where excavation was taking place. So here you can see them displayed on the map in the alarm system, and so in this case this alarm could be communicated to a UAV, and that could be dispatched to site. But in this particular case, this was a few years ago, before we had this technology, and so people were sent to site. They took a while to get there, and as you can see, they'd already dug down to the depth of the pipeline. Now in this particular case, it was unplanned maintenance. The team involved knew that the pipeline was there, they were careful, and they hadn't damaged it. But this was news to the pipeline operator. They hadn't been notified of these works, and therefore it was quite concerning that this could have happened. So a UAV would have really helped them here and given them a peace of mind. So another concern with pipelines is leaks, and over recent years DAS technology has developed and has been proven as a good means of detecting a leak from a pipeline. It recognises vibrations caused by fluid escaping from the pipe, and also other effects such as ground heave, negative pressure waves, and sometimes temperature effects around the pipeline. Now once a leak is detected, we want to respond quickly, because what really matters is the amount of product that escapes from the pipeline, and that is a product of the flow rate of the leakage and the time we take to stop it. So if we could fly a UAV out to the site, we may be able to see evidence of the leak at surface, but at the very least we'll be able to drive away people or animals that may be in the area of danger, give them warning, and it could carry some onboard sensors to inspect the surface, and possibly carry a spill kit to provide a first line of defence. So we really think this is an excellent technology going forward. It combines the excellent sensing ability of distributed acoustic sensing with the rapid response of UAVs. So we're able to sense the specific threats and distinguish what is a threat from background noise using a DAS sensor. And then we can provide a clear alarm with a high degree of confidence and give an accurate position of its location, so that then we can respond with a UAV. That is a rapid way and a safe way of responding to a threat anywhere along the route of the pipeline. And when the UAV reaches site, it gives a bird's eye view, allows us to identify the threat, and provides ongoing tracking of the people involved if there's a crime that's going on. So we react quickly, provide a deterrence, and help clients preserve their reputation by not suffering damage or leakage from their pipeline. And ultimately, that can only save you money. So thank you very much for listening. Really appreciate it. Please do contact me for more information on my email address, which is provided here. Stuart.large@fotechsolutions.com. Thank you very much. Goodbye.